The distribution factor is an empirical computation provided by AASHTO to identify the actual live loading applied to the girders. Check this example here in bridge engineering. The example involves a single-span bridge of 24 meters length. The deck is 200 mm of reinforced concrete, and it is supported by steel girders which are spaced equally at 2600 millimeters. The steel girders have a cross-sectional area of 28,500 square mm, with moment of inertia of 5.5 times 10 raised to 9 millimeters raised to 4. The vertical distance from the center of the girder to the center of the deck is measured as 425 millimeters. It is also stated in the problem that steel is taken as 8 times stiffer than concrete. We are to look for the distribution factor for the bending moment of an interior girder when 2 or more lanes are loaded. Let's illustrate the bridge to visualize the given parameters. The bridge is single span of 24 meters length and composed of a concrete deck and a steel girder. The girders are equally spaced at 2,600 millimeters. For the steel girders, the cross-sectional area is given as 28,500 square mm, and its moment of inertia is 5.5 times 10 raised to 9 millimeters raised to 4. With this is the deck with 200 millimeters thickness, and also given is the distance between the center of the girder to the center of the deck as 425 millimeters. One important parameter in the solution of the distribution factor is the longitudinal stiffness, which is computed as N times the quantity of I plus A times E sub G squared. N is the modular ratio, which compares the modulus of elasticity of the girder with the deck. From the premise, it was compared that steel, which is the girder, is 8 times stiffer than concrete, which is the deck. Next is the I, or the moment of inertia, which was given as 5.5 times 10 raised to 9. Then A, or the cross-sectional area, also provided as 28,500 square millimeters. The last parameter is E sub G, which is the lever arm, and it is solved using the equation, although the premise is stated that the distance between the center of the girder and that of the deck is 425 millimeters. With all these parameters already determined, we can compute for K sub G as 8 times 5.5 times 10 raised to 9 plus 28,500 multiplied by the square of 425 mm, and this results to 8.518 times 10 raised to 10 millimeters raised to 4. The task is to identify the distribution factor of an interior girder when 2 or more lanes are loaded, where the appropriate equation is as follows. Most of the parameters have already been given, and we just determined K sub G, so let's begin with the computation. The spacing term is taken as the girder span of 2.6 meters all upon 2900, and the quantity is raised to 0.6. This gives 0.937. Next is the span ratio term, S over L raised to 0.2. We have the girder spacing again as 2600 and the bridge span of 24 meters. Raise the whole quantity to 0.2 and get 0.641. The last is the stiffness term, which is solved as the previously computed K sub G of 8.518 times 10 raised to 10, which is divided by the bridge span of 24 meters multiplied by the cube of the deck thickness given as 200 mm. The term is simplified as 0.922. Thus, the distribution factor is 0.075 plus the product of 0.937, 0.641, and 0.922, which gives 0.629. This means that each interior girder carries 62.9% of the total lane moment.